Like any star, it will run out of fuel in its center, and it begins transforming. It begins swelling, it will overwhelm the orbits of Mercury and Venus, and come exceptionally close to Earth. Betelgeuse is dying. This news has been a hard pill for researchers to swallow, but there is nothing they can do about it because the massive star is going to go supernova soon. Astronomers say it could be tomorrow, a month from now, or a few months from now. They don't know the exact date, but one thing is certain: the famous Betelgeuse has reached its end, and its demise is going to transform us. Why is the Betelgeuse supernova so extraordinary, and why has it got everyone scared? What might occur if this star exploded today, as scientists have predicted? Join us on this fascinating journey as we explore the answers to these questions in today's video. NASA's chief announces that Betelgeuse's supernova is imminent in 2024. It's over, and there's no hope to stop the looming destruction. NASA's chief cries out, warning the world about the approaching Betelgeuse supernova that could change the trajectory of the planet and life as we know it. Betelgeuse's end is inevitable. Like a critically ill patient, it is moving closer to its grave. It's just a matter of time before this renowned star explodes and ceases to exist. For years now, astronomers have been captivated by Betelgeuse, spending time studying its dynamics and its impending explosion. What astronomers have long dreaded is about to happen. There's no stopping the inevitable. Betelgeuse is headed for destruction, and its end is coming sooner than expected. Betelgeuse is one of the most remarkable stars in the Milky Way and has fascinated astronomers and stargazers for centuries. For a long time, astrophysicists have been hypnotized by this reddish semi-variable star, whose apparent magnitude fluctuates between 0.5 and 1.6. Compared to other stars, Betelgeuse stands out as a first-magnitude star with the widest range. The classical astronomer Ptolemy, an Alexandrian mathematician, astrologer, astronomer, and geographer, spent years studying Betelgeuse. His research and observations gave astronomy one of the earliest descriptions of this red giant star. It might entertain you to know that even indigenous groups in South Australia have shared oral stories of the very variable brightness of Betelgeuse for at least 1,000 years. However, advancements in astronomy have provided stargazers with a more accurate picture of Betelgeuse and its characteristics. The red supergiant star is located in the constellation Orion and is one of the largest stars out there. Red supergiant stars are some of the biggest and most massive stars in the universe. Their diameters range from 100 million to 1 billion kilometers, making them one of the marvels of the Milky Way. If we were to place Betelgeuse near the Sun, the star would be 100 to 1,000 times wider than our Sun. Research tells us that a red giant star is a dying star in the final stages of evolution. Despite the similarities between a red giant and a red supergiant, there's a significant difference. Unlike a red giant, which forms when a star with the mass of our Sun runs out of fuel, a red supergiant emerges when a star with more than 10 solar masses enters this stage. A red supergiant star occurs when it runs out of fuel to burn in its core. As the star depletes its fuel, it can no longer create the heat and pressure needed to support its weight, causing it to collapse. Betelgeuse's astonishing character extends to its brightness, as it is the 10th brightest star in the night sky and the second brightest in its constellation, behind Rigel. However, if we were to observe Betelgeuse at near-infrared wavelengths, no other star would surpass it as the brightest star in the night sky. The Sun's brilliance pales significantly when compared to the immense frame of Betelgeuse. The red supergiant's radius is 1,000 times that of the Sun. If we could somehow place Betelgeuse at the center of our solar system, its surface would extend beyond the asteroid belt, engulfing the orbits of Mercury, Venus, Earth, and Mars. Estimates suggest Betelgeuse's mass is 10 to 20 times that of the Sun. The most stunning discovery about this star is that it is only 600 light-years away from the Sun, meaning it is relatively close in astronomical terms. Astronomers were stunned when they realized that Betelgeuse is less than 10 million years old. By cosmic standards, it is a young star, a child compared to our Sun, which is around 5 billion years old. However, what Betelgeuse lacks in age, it compensates for in size, dwarfing most of the stars in the universe. Despite scientists' best efforts, determining Betelgeuse's exact diameter has been a Herculean task because it is a pulsating star, meaning its size changes over time. Betelgeuse's death is near. The red giant star is expected to meet its end when it experiences a supernova explosion anytime soon. The scientific community has been on high alert ever since astronomers discovered that Betelgeuse is destined for a supernova. A supernova is a powerful and luminous explosion of a star, occurring during the final evolutionary stages of a massive star or when a white dwarf triggers runaway nuclear fusion. If Betelgeuse explodes today, the peak. The optical iridescence of a cosmic explosion can be contrasted with that of a whole system, prior to blurring after a little while or months. The sheer sight of this event would either terrify or invigorate its watchers. Another charming fact about this red giant star is that it is visible to the naked eye at night. However, scientists still can't explain the truth that the red supergiant is nearly undetectable from Earth between May and August, as it is close to the Sun during this period. This is one of the mysteries surrounding Betelgeuse. Another exciting fact to remember is that Betelgeuse is one of the 3 stars that make up the winter triangle asterism, and it marks the center of the winter hexagon. At the beginning of January each year, the star can be seen rising in the east just after nightfall. By mid-March, it is visible to almost every inhabited region on Earth, except Antarctica at latitudes south of 8 degrees. So, on a typical day, once daylight says goodbye to the Earth and night sets in, it is possible to spot Betelgeuse among the array of stars that adorn the sky. If Betelgeuse were to explode today, everyone would see its consequence. It would be as visible as if we were watching a 3D live-action film. Everyone would know that something extraordinary had occurred in the Milky Way. The supernova would appear as a very bright point of light in the sky, possibly even creating shadows at night. Betelgeuse's supernova would shine as brightly as the half-moon for over 90 days, altering the face of what happens on Earth. If you doubt this, remember that Betelgeuse is only 642 light-years away from Earth, relatively close in astronomical terms. There's no escaping the inevitable, we are bound to feel the impact of this powerful explosion. Before delving further into the potential impact of Betelgeuse's explosion, it's essential to note that the star's brightness is not constant. This may come as a surprise to many, but it shouldn't. Betelgeuse is a pulsating semi-regular variable star, which helps explain why it undergoes various cycles of increasing and decreasing brightness due to changes in its temperature and size. The first time astronomers reported this peculiarity about Betelgeuse was in 2019. Credit goes to Villanova University's Jason Richard Wasatanek, Edward Guinan, and amateur astronomer Thomas Calderwood. They were the first to notice Betelgeuse's diminishing brightness, an event that seemed dreamlike at the time since nothing like this had been observed before. After conducting numerous tests, scientists concluded that it was indeed real. They hypothesized that the event was caused by an ordinary 5.9-year light cycle minimum, and a deeper-than-normal multi-day period was responsible for the unusual occurrence. By late 2019, theories of other potential causes arose, suggesting the event could have been caused by an ejection of gas or dust, or fluctuations in the star's surface brightness. In the succeeding months, astronomers spent time investigating this sudden event. Thanks to ultraviolet observations made by the Hubble Space Telescope, HST, a new theory was proposed. By August 2020, scientists believed that the dimming may have been due to a massive amount of very hot material ejected into space, which eventually cooled and formed a dust cloud that blocked the starlight from about a quarter of the star's surface. What's interesting is how the Hubble telescope had captured signs of dense, heated material moving through the star's atmosphere in September, October, and November, before several telescopes observed more pronounced dimming in December. In the first few months of 2020, when January came, astronomers found that Betelgeuse's brightness had dimmed by a factor of about 2.5, from a magnitude of 0.5 to 1.5. Things worsened in February when scientists reported that the star was the least luminous and coolest it had been in 25 years of studying it. As soon as news of this event reached the public, speculation arose that Betelgeuse might explode as a supernova. This story spread further when NASA's communications shifted in the same direction. However, normalcy returned when, by February 17, 2020, Betelgeuse's brightness remained steady for around 10 days. Furthermore, scientists began to smile again because the star showed signs of re-brightening. By February 22, Betelgeuse was believed to have stopped dimming completely, casting a shadow over the dimming episode. Further studies conducted on February 24, 2020, brought a new perspective to our understanding of the possible cause of this event. Scientists announced that large-grain circumstellar dust might have caused Betelgeuse's dimming. We thought this dimming episode was a thing of the past until a fresh discovery arrived in March 2024, suggesting Betelgeuse was dimming again. This was validated by the American Association of Variable Star Observers, AAVSO, which reported that Betelgeuse had dimmed by about 0.5 magnitudes since late January. This revelation made headlines on March 14, 2024, leaving everyone on edge as we await what happens next. If we pause for a moment to stop talking about Betelgeuse's brightness fluctuations, we can't help but notice the real elephant in the room. Will Betelgeuse explode soon? Betelgeuse's approaching blast, and the possibility of what the Betelgeuse blast could do to our planet, has sent numerous into a condition of frenzy. Minds have roamed free on the vast conceivable outcomes that could emerge from this occasion. Anyway, stargazers rush to relieve everybody's feelings of trepidation and have spent time guaranteeing us that life on Earth will be safe. They have even gone further to declassify records that show that Betelgeuse's blast will occur within 100,000 years, so it very well may be centuries from this point before it happens. As consoling as these explanations might sound, a few space experts continue to paint a violent picture of what could happen to our planet. For the people who will be alive when Betelgeuse detonates, they would see that the star sparkles far more brightly than any other star or planet. The energy released during Betelgeuse's blast could have a serious impact on the surrounding space. It's alarming that we are yet to determine the extent of its effect on our planet. Assuming we are being straightforward with ourselves, there is a reason to be frightened of a blast that would release a gigantic amount of energy, estimated to be as much as the energy released by the sun in its entire lifetime. That blast is a lot of radiation coming from just one event. All that radiation, including gamma rays, X-rays, and cosmic rays, would no doubt significantly affect Earth's environment. Some scientists even fear it could be destructive to life on Earth. Researchers have admitted that this radiation can damage DNA and other cell structures and potentially cause cell death, mutations, and cancer. So it's in our greatest interest that this radiation never reaches our planet. The potential health issues that might arise are indeed terrifying. Nevertheless, studies have shown that it's not all doom and gloom as some projections might have us believe. Astronomers have reassured us that Earth's atmosphere is capable of shielding us from most of the harmful radiation that might be released when Betelgeuse goes supernova. Thus, in contrast to our fears, it would only have a minor impact on life. We see evidence of this possibility when we consider the fact that the brightness of Betelgeuse's supernova would create shadows at night. This event isn't great news for nocturnal creatures that rely on darkness to hunt, navigate, and communicate. Owls, for instance, present us with a clear example of this possibility. Nocturnal creatures depend on intense night vision to hunt and navigate in the dark. However, creepy-crawly Juice's blast is going to turn the tables on these innocent creatures. The increased brightness caused by the supernova could interfere with their ability to see in the dark. This is a significant problem because it could become harder for owls to hunt and avoid predators. Moreover, certain bugs like fireflies, which use bioluminescence to communicate with one another, may have their activities interrupted. This is because the increased brightness from the supernova could impede their ability to communicate with their companions in the firefly world. Besides, this could alter their behavior and mating patterns. Creatures are not the only ones at risk of being affected by the supernova. The increased brightness could affect the ecology of the area. Take, for example, the way increased light pollution could disrupt the migration patterns of birds and influence the behavior of insects. When this happens, it is only a matter of time before the balance of the ecosystem is disturbed. A look at some of the models conducted to assess the extent of the supernova's impact shows that it could cause changes in the ozone layer and temporarily alter the climate. If we take our focus off the environment for a moment, we will realize that Betelgeuse will also have an impact on astronomy. The event will undoubtedly give stargazers a unique opportunity to further explore the properties of a supernova. Moreover, researchers will get to learn more about the life cycle of massive stars and uncover facts about this phenomenon that we never knew existed. Hopefully, this new star can live up to its cosmic beauty. For now, we must keep our fingers crossed for whatever beautiful story the universe intends to write with Betelgeuse's supernova.